You come to on Io, Jupiter's innermost big moon, and the first thing you notice is that the ground is breathing. Not metaphorically, actual solid rock is slowly rising and falling beneath you as Jupiter's gravity grabs the entire moon and kneads it like pizza dough. Every few hours, that gravitational squeeze flexes Io's interior so violently that rocks grind, melt, and turn into oceans of magma beneath your feet. You take one cautious step, and in the distance, a volcano casually erupts. Straight into space. Io has over 400 active volcanoes, the most of any world we know. Lava fountains can shoot hundreds of kilometers high, and entire regions are coated in frozen sulfur and sulfur dioxide that look like someone let a toddler redecorate a planet with toxic highlighters. You're standing in a place where the landscape is basically a geological rage tantrum that never stops. You look up, hoping the sky will be comforting. Bad move. You're parked inside Jupiter's radiation death field. Io orbits deep in the planet's magnetosphere, where charged particles scream around like invisible bullets. On Io's surface, the radiation dose can reach tens of thousands of millisieverts per day, tens of thousands of times what you'd get on Earth. Enough to kill you in short order, even if you somehow avoided getting cooked by lava. Your cells are not just dying, they're being turned into a biology-themed demolition experiment. The temperature adds insult to injury. Io's average surface is around minus 130 degrees Celsius, cold enough to freeze sulfur dioxide into snow, even as nearby lava lakes glow at over 1,000 degrees. You're in a place where you could get frostbite and third-degree burns within walking distance. It's like standing between two ovens, one full of dry ice and one full of molten rock, and realizing you're the undercooked entree. You try to move carefully, but every step risks crossing a lava flow that wasn't there yesterday. Io's surface is constantly resurfaced by eruptions, so maps are basically lying suggestions. You're walking across a world that is literally rebuilding itself in real time and does not care at all if you happen to be standing on the patch currently being deleted. But what do you do when the universe decides to skip the fire and go straight to the radiation slow cooker? You blink and now you're lying face down on a sheet of ice that stretches in every direction, flat, pale, and cracked like an ancient windshield someone smacked with a planet-sized hammer. Welcome to Europa, another of Jupiter's moons, where everything looks calm until you remember the words Jovian radiation and no magnetosphere. You've basically spawned on hard mode inside a microwave with frostbite. You stand up and check the sky. Jupiter looms overhead like a god that's seen your search history. Europa doesn't have its own protective magnetic field, so Jupiter's radiation belts dump brutal doses of ionizing radiation straight onto the surface. If you stayed out here unshielded, you could receive several sieverts of radiation in a day, enough to give you a 50-50 shot at dying of radiation poisoning within a month. Translation: this moon is trying to speedrun your lifespan. You look down at the ice and start to realize the ground is just as sketchy as the sky. Europa's crust is a cracked, ridged shell of water ice tens of kilometers thick, floating on what's very likely a global subsurface ocean. Those spiderweb cracks and ridges? They exist because Jupiter's gravity flexes the moon, generating tidal forces that slowly shift and deform the ice. You're essentially standing on an ice cap over an ocean that's being kneaded like dough by a distant gas giant. Every so often, the ice shifts. On icy moons like Europa, moonquakes and flexing of the crust can trigger landslides or cause blocks of ice to raft around, leaving chaotic terrain, vast jumbled fields of broken slabs frozen mid-collision. You take a step and realize that the perfectly flat-looking patch ahead is actually a slanted plate of ice waiting for the next quake to send it sliding. You, naturally, are the squishy bonus DLC riding on top. Europa is so cold that the surface sits well below minus 150 degrees Celsius. Any exposed skin would flash freeze, and your lungs would fail immediately in the near vacuum. There's almost no atmosphere to speak of, so you're not breathing. You're simply decorating the landscape with a thin, regret-flavored mist. Meanwhile, radiation is quietly rewriting your DNA like a very lazy but thorough vandal. But the worst part is the paradox. Beneath you, in that dark, tidally heated ocean, there might be the perfect conditions for life. Liquid water, energy sources, chemistry stirred by radiation interacting with surface ice. Life could be thriving down there, happily oblivious to the fact that you're dying on the crust like a badly timed delivery. So what do you do when the safest place on the moon is an ocean you can't reach before the surface finishes killing you? You come to again on a dim gray plain. It feels calmer. No immediate lava fountains, no screaming ice fractures, just a huge cratered surface and a sense that the silence is only pretending to be friendly. This is Ganymede, the largest moon in the solar system, bigger than Mercury, and for about 3 seconds you think, okay, maybe this one isn't so bad. Cute optimism. You look around and the first thing you notice is how dead everything looks. The terrain is a mix of darker, older regions stuffed with craters and brighter, grooved areas sculpted by ancient tectonics. It's a Frankenstein world stitched together by past upheavals. No atmosphere worth mentioning means no sound, no wind, and no helpful air to breathe. Every exhale is just another tiny cloud of ice crystals announcing how temporary you are. Ganymede actually has its own magnetic field, the only moon in the solar system that does, which sounds comforting until you remember the neighborhood it lives in. It's still orbiting inside Jupiter's massive magnetosphere, which means charged particles are whizzing around, slamming into the surface and into you. You're getting irradiated, just with slightly different flavoring. It's like swapping from being hit by a truck to being hit by a slightly smaller truck that's on fire. You start walking and the ground feels solid, but the danger is time. With almost no atmosphere and low gravity, your body's moisture wants to boil off. Exposed tissues would swell, your blood would lose oxygen, and you'd black out in seconds. The cold finishes the job shortly after. The calm you're feeling is just the quiet efficiency of physics, not kindness. Ganymede doesn't need volcanoes or diamond storms. Vacuum and radiation do the job nicely. The really unsettling bit? Ganymede probably also has a deep subsurface ocean, maybe layered between sheets of high-pressure ice, where conditions could be interesting for life. So, just like Europa, there may be an entire hidden biosphere sealed away while you're dying upstairs in slow motion. It's like suffocating on the roof of an aquarium, which makes you wonder, what happens if the moon itself starts shaking under you instead of just politely killing you with vacuum? Suddenly, things look familiar. Gray dust, scattered rocks, a black sky, and a huge blue-white marble hanging overhead. You're on our moon, and for a moment, nostalgia hits. This is the place humans actually walked, planted flags, and almost pretended it was safe. Then the ground shivers and reality taps you on the helmet. You look down and you're standing on regolith, a layer of razor-sharp, fine dust created by billions of years of micrometeorite impacts. This dust doesn't behave like Earth's sand. It clings, scratches, and gets everywhere. Breathe it in and it can shred your lungs. Get it in joints or seals and it grinds them down. You realize every step you take is basically walking on microscopic glass that hates your lungs and your equipment equally. Then the moon decides to do its party trick, moonquakes. Unlike most earthquakes, some shallow moonquakes can reach magnitude 5.5 and last for over 10 minutes. Because the moon's dry, rigid crust rings like a bell. Imagine the ground under you vibrating steadily for that long, with no atmosphere to muffle anything. Your habitat, if you had one, slowly rattling apart while you stand in the middle of a silent, invisible drum solo. Without a real atmosphere or magnetic field, the moon is exposed to solar and cosmic radiation. On the day side, temperatures can soar above 100 degrees Celsius. On the night side, they plunge below minus 150. If your suit fails, you don't get a dramatic Hollywood explosion, you just quietly boil, freeze, and suffocate in a grim little physics sandwich. The worst part is meteoroids. With no air to burn them up, even tiny bits of space debris slam straight into the surface at hypervelocity. You could be standing there, minding your own business, when a pebble-sized rock from deep space hits nearby with the energy of a grenade. There's no sound, just a sudden geyser of dust and shards that can slice through you or your shelter. So if the moon can feel this hostile, and it's our nice neighbor, what happens when you visit a moon where the atmosphere itself is trying to erase you? You wake up to a thick orange haze and, miracle of miracles, you're not instantly dead. You're on Titan, Saturn's largest moon, and unlike almost every other place we've been, this one actually has an atmosphere thick enough that you could, in theory, survive a few minutes with just an oxygen mask and heavy insulation. That's the good news. The bad news is everything else. Titan's atmosphere is mostly nitrogen with a dash of methane and complex hydrocarbons, giving the sky a permanent orange smog vibe. The air pressure at the surface is higher than Earth's, so your body doesn't explode. Instead, you slowly realize you're standing in an alien tundra freezer where the temperature is around minus 180 degrees Celsius. At that point, everyday materials you take for granted, like some plastics, start behaving more like glass. You trudge forward and stumble onto the shore of a lake, except it's not water, it's liquid methane and ethane, filling vast lakes and seas. Fall in, and your body becomes a popsicle in a hydrocarbon smoothie. Your lungs wouldn't even get the chance to complain before freezing, and your suit, if it's not absurdly over-engineered, would crack like cheap plastic in a deep freeze. Titan's low gravity, about 1/7 of Earth's, means you could strap on wings and literally fly by, jumping and flapping, which sounds fun until you realize every surface is slick with hydrocarbon ice and organic gunk. It's like trying to explore a planet-wide frozen oil spill. You slip, you crash, and if you tear your suit, the atmosphere and cold finish you off like a very patient executioner. And beneath all this, there may be another subsurface ocean of water mixed with ammonia, kept liquid by tidal heating and radioactive decay. Life might be possible here too, whether in that buried ocean or in the weird chemistry of the surface lakes. So while you're slowly freezing solid in the smog, something microscopic could be thriving in a chemistry lab straight out of a science fiction fever dream. But what happens when the moon looks quiet, small, and unimportant, and still manages to be one of the most brutally destructive worlds we know? You blink and now you're standing on something that looks almost peaceful, Enceladus, Saturn's tiny, bright white moon. The surface is gleaming ice, smooth in some areas, scarred with fractures and ridges in others. For a moment, you think you've finally arrived somewhere that looks like a postcard instead of a crime scene. Then the ground near the South Pole erupts into space. You make your way toward the Tiger Stripes, 4 massive parallel fractures near the South Pole, from which jets of water vapor, ice grains, and organic molecules blast into space like a constant freezing geyser storm.
These plumes come from a subsurface global ocean of salty water, heated by tidal forces as Enceladus flexes in Saturn's gravity.
It is, scientifically speaking, one of the best places in the solar system to look for alien life. It is, personally speaking, one of the worst places to go for a casual stroll. If you wander too close to a plume, you're essentially walking into a vertical blizzard of ice shards being shot upwards at hundreds of meters per second. Your suit would be sandblasted by microscopic bullets, your visor pitted and cracked, and if you were somehow unprotected, the near vacuum and extreme cold would freeze dry you into an astronaut-shaped crouton. You don't fall into the ocean here. The ocean aggressively tries to leave the moon and take you with it. Like the other icy moons, Enceladus has almost no atmosphere, which means instant suffocation without a suit, and the temperature sits around minus 200 degrees Celsius. This is the kind of cold where touching metal with bare skin isn't a bad idea. It's a fast way to donate your fingers to planetary science. The only reason this place isn't as immediately lethal as, say, Io, is that it chooses style over speed. But the most unsettling bit is philosophical. That ocean beneath the ice could harbor hydrothermal vents and chemistry not unlike Earth's seafloor, where life may have started. This tiny ice marble might be more alive on the inside than Earth's moon has ever been. You're standing on the skin of a world that might be hiding an entire ecosystem just out of reach. And if the scary moons can be this varied, what happens when we start discovering hundreds more around distant planets we can barely see? If you made it through that grand tour of moons without mentally canceling your vacation plans to Jupiter and Saturn, you're tougher than you look. I just dragged you across lava oceans, radiation baths, ice-quake death traps, methane seas, and geysers that launch atmosphere straight into space, and somehow you're still here. Well, emotionally at least. If you enjoyed being cosmically bullied by geology and physics, let me know in the comments which moon you'd least want to wake up on. Hit like so the algorithm knows you survived, and subscribe to CosmoBinge so we can keep throwing your imagination onto even worse planets next time.